In this video, I'm going to introduce materials for Chapter 1 of Year 11, or the Preliminary HSC for Engineering Studies. And what I'm going to look at what we're going to cover, and I'm going to then go over M1 and M2. So as an overview, if we just look at the notes, so we're going to look at the classification materials, we're going to look at material properties, we're going to look at the structure of materials, we're going to look at then specific materials, the 4 classifications, metals, polymers, ceramics, and composites. I have covered some of this stuff in I've already recorded most of these videos already. I'm actually going backwards to record this first video. So there's plenty of these things which I've already covered, like some materials 4 that's forming, metals and bonds. And I'm going to go through a little bit more of an introduction showing the Facebook notes that I use. So for the most recent class that I'm recording, I have most of those notes that relate to materials are on these pictures. We'll have a look at them one by one. So following along with the Copeland textbook, so this is Copeland Engineering Studies Definitive Guide. This is the previous version, but it's still pretty good. Just the page numbers might not line up to what the version that you might be looking at. Okay, so if we look at materials, first thing we're going to do is going to classify materials. So we talk about elements, solutions, compounds, mixtures, those sorts of things you probably already covered in chemistry. We talk about metals and non-metals, and then we define the non-metals as ceramics, polymers, and then we talk about composites. When we get to a little bit further, we'll talk about states of matter, but next we're going to look at properties of materials. So for properties of materials, I have material properties. That's Real Engineering does a pretty good video. I talk about some things like magnetism. We're going to go through this as in today's video. So states of matter are next. So okay, structure of materials. So we need to know about things like protons, neutrons, and electrons, and the way that they exist as states of matter. So I have this video. These are 3 videos that relate to Eureka videos. I should change that, but I probably won't. The next thing we're going to look at is that most solid... okay, so that's got some bonding stuff there as well. That's all covered in subsequent videos, I think in part 2. Then we're up to... We're up to metals? Yeah, okay, so metals... Where do we have crystals? Where are crystals covered? I'll just check that I do that in the right order. I may have skipped crystals. There we go, I sell them on the way up. Here we go. So crystal structures are next. So crystal structures are linked to this picture. So then we're up to ferrous metals. So ferrous metals are metals that contain mostly iron, predominantly iron. Then we're going to look at non-ferrous metals. We're really focusing on copper and aluminium. So I do have an aluminium picture, but I don't use it until year 12 because we don't really cover aluminium in depth until year 12. Then we have fabrication methods. So this is how we make things out of metals. So we have things like casting, rolling, extruding, and then for welding or joining metals, we have a whole set of posts on here. So we've got the different kinds of welding. And then we've got polymers. So polymers is the engineering term we use for plastics. So it's polymers. And then the fabrication methods for polymers. So mainly we're focused on injection molding, but I do cover a few other examples that are used, that are commonly used. Then next we have ceramics. I think it should be next. Okay, ceramics is next. So in ceramics we look at things like brick and glasses and cement products, and we also talk about things like insulators, abrasives, and transistors. Lastly, we have composites, and a picture. Oh, okay. So I have a bit more detail on glasses there, and then composites. We're mostly focused on concrete, so we have like concrete cancer. I've got some geotextiles there, a few other things that we'll worry about when we get further down to the course. So that's what we're going to look at in this chapter. It's a pretty important chapter. It's fundamental for what we do. So let's go through, we're just going to go through this one page today. So we're going to look at M1, M2. We're going to look at the classification of materials, and we're going to look at the properties of materials. So for the classification of materials, in engineering, we classify everything as metals or non-metals. And then we could say there's really 4 categories. We say metals, ceramics, polymers, and composites. So that should be metals, ceramics, polymers, and composites. Then we have the properties of materials. So we need to explain what, when we say that a material is hard or tough or strong, what do those things mean? So I'm going to give you some definitions that you can use now. So let me get that open. So Copeland has some definitions which are good, and that I won't go into too much detail, but worthwhile, and definitely I'll never mark things wrong if you write Copeland's definitions. But first of all, with properties of materials, what we want to say is that mechanical properties cover a whole bunch of things. They cover these, 7 or 8 things. And then everything else, chemical properties, physical properties, I think are quite intuitive, and I don't think they need to be spelled out in nearly as much detail. So as engineers, we're really interested in this first group, mechanical properties, and you'll notice that that's what I've got on this page here. So what we want to know is, if we say that something is strong, what does it mean if I say that something is strong? Yeah, okay, so an answer is that it can't break easily. That's a really good answer, but it's not good enough for an engineering answer. What we want to say, so the answer that Copeland says is the ability to withstand load, but I don't like that. I want to go a little bit further. I want to say it's the ability to withstand stress. We've already covered what stress is at this point, so we're going to say that strength and stress are 2 sides of the coin. They're both measured in pascals, and stress is the ability to withstand stress, how much stress you can withstand. Okay, so it's measured, I'm going to say that again. Strength is the ability to withstand stress. It's measured in pascals. Okay, the next definition is hardness. Can you tell me what hardness is? Okay, so hardness is the ability to withstand wear or scratching or indentation or abrasion. Now, I think that from an engineering perspective, we're most interested in its ability to withstand wear. But if you're talking about glass, then the ability to withstand scratching is really important. Indentation is how we measure it in practice. So we use hardness testers like the Brunel or Vickers hardness tests, which we will learn more about how we test these materials later. How quickly can I find those notes? We haven't covered it in... We're not going to cover it in this chapter, so I won't go into it in too much detail, but it is something we have covered. I've obviously covered with Year 12. Typically, I'll just go through it very quickly and show you where that is, or what it will look like when you get up to it. So testing, I use this picture of Sam Rockwell as the hammer in Iron Man 2. And we talk about the ISOD test for toughness, and I just have a whole bunch of links to different kinds of testing and some past HSC questions. Okay, so hardness, how we test it is we test it with a hardness tester, so the Rockwell hardness test, for instance. And we know that diamond is the hardest material, and we know that glass is sort of in the middle, and that typically steel will scratch glass, but not always. So Gorilla Glass has a hardness harder than my keys, for instance, and some metals. So in other videos I've talked about when we do testing, we saw that chocolate can be harder than steel. I have recorded this elsewhere, so hopefully I've done that in another chapter. If I haven't, ask me and I will find you the notes where I have chocolate harder than steel. Okay, so the definition, I'm going to say that again. If you said resistance to scratching, hardness is a measure of resistance to scratching, I would give you full marks for that. If you said the hardness is resistance to wear or abrasion, I would give you full marks for that as well. If you said that hardness is the resistance to indentation, I'd give you full marks for any of those. Okay, the next one is stiffness and elasticity. So for elasticity, The definition that I'm going to give is the ability to return to its original shape. Right, so the idea is that Copeland goes into it in slightly more detail, but the idea is that something can be deformed and then it will return to its original shape when the load is removed. That's what elasticity is. Stiffness is a measure to the resistance to elastic deformation. That's the definition I'm going to give. We'll later, when we do testing, we'll get better and better definitions. For the moment, that's the definition I like. Stiffness is the measure of resistance to elastic deformation. Okay, we've got plasticity. Plasticity is the ability to be permanently deformed. So we know that a steel ruler, we can spring, or we can buy a steel spring, but a steel ruler is, I think, something a lot of students are familiar with, that you can dung, dung, dung on the side of a table. But there's always that point where that kid pushes the ruler a little bit too hard and now it's bent. And you can't really bend it back into its original shape perfectly. So that point where things now will hold their shape is called plasticity. A spoon is another example. You can bend a spoon out of shape. Cars, we wouldn't be able to make cars out of steel if we couldn't permanently form steel into new shapes. Malleability and ductility, they have commonly used or their original definitions, and then I have a more specific engineering definition. Malleability, what you'll learn in Year 8 or 9 science, is that malleability is the ability to be hammered or rolled into a sheet. Mallet is the obvious analogy there, so that a mallet can be hit with a hammer into a sheet. Ductility is the ability to be drawn into a wire. I personally like the idea that malleability is the ability to be deformed under compression, and ductility is the ability to be deformed under tension. But if you give those other more intuitive definitions, I'm happy with those as well. Okay, fatigue is the tendency to fail under cyclic load. The idea is that things like planes, which are under repeated, even though it's very small amounts of load, way less than what it needs to fail, it eventually can fail because it's just so persistent and repeated in a cyclic manner. So the idea, the analogy I use here is that your strength, you might be able to bench press, I don't know, 80 or 200 kilos, whatever it is. But there's a point where if I said to you, I just want you to lift the bar with no other weights, and the bar might be 20 kilos, I just want you to lift the bar over and over for 3 days. Well, eventually there's going to be a point where you're just going to get too tired that you can't keep lifting the bar forever. So even though it's well and truly under the limit that you can lift, it's just if I ask you to do it for long enough, eventually you're going to fail. Okay, the last one that we have is toughness, and my definition of toughness is resistance to impact. Copeland has a different definition. I'm not going to go into that here. You can look at that. If you give either of them, in the class, I will mark that as correct. So if you talk about energy to cause failure, I will also mark that as correct. But for me, when we talk about things like that IZOD hardness test, it measures the impact, the impact that it can withstand. Okay, so we will just quickly mention that chemical properties measure how well materials resist corrosion. So I've left the word measure, or how well materials resist corrosion or react to the environment. The environment or the environments. Yeah, there's some typos. Physical properties include density and porosity. Thermal properties describe how well a material conducts heat and its rate of thermal expansion. Electrical properties measure the resistance or conductivity, but we're going to say with the resistance to electrical current. Magnetic properties are described in a fair amount of detail on page 13, and like I said in my notes, I have a fair bit of stuff on magnets. So magnets, pretty tricky. Richard Feynman, who's a pretty famous physics teacher, made a video talking about that. Now, I have a summary of what I've just written here. You should be able to find these on the Facebook notes, or I may have even typed them for you and included them in the link, which you can see I currently have not yet done. Okay, that should get you started, and there's plenty more videos on materials.